So we're going to talk about a few things that can go wrong with inheritance, or at least a few things that can be tricky about using inheritance in practice here. In the previous part, we did an example with inheritance where I made a print table function where you could pass in an arbitrary formatter and then use that to make outputs in different formats. The way that that worked is we had a portfolio of these holding objects, and then what you could do is make a formatter object, like formatter is equal to table, text table formatter, for instance. And then you could say table, print table, portfolio, and then drive it by passing in a formatter object. Again, a way of writing extensible code. Let me talk about a couple of things that might go wrong, or at least cause headaches. One thing that gets a little bit tricky is a situation is involving attributes. Let's say this top-level table formatter class had an init method. Like maybe it had an option for specifying an output file. Right now, all these tables are just being printed to the standard out. Maybe you didn't want that. Maybe you wanted to give the option to have like an output file. So maybe if the output file was equal to none, we would just default it to sys.standardout. Standard out is where printing normally goes in Python. So it's a file where that gets redirected. So maybe if you don't specify where it's going, we're going to set that. And then let's say we set an attribute on the base class. Let's say you had this, had some kind of special initialization there. And let's say you had code that used that. In order to use that output file, you would modify the different methods to essentially redirect to that file. I'm not going to do this for like all of the methods, just in the interest of time, but you get the idea here. Let's say you made that modification. It turns out that you can run into some somewhat head-exploding issues if some of the child classes also want to have like an attribute. Like let's say the text table formatter, let's say you wanted to specify a width. Like right now, this thing is printing in a 10 wide column. Maybe we wanted the width to be customizable. It's like a configuration thing. All right, so let's say you wanted to have a width like that. Here's the problem. This attribute of the width, it's kind of in collision with the attribute from the base class. Like the base class needs to have this outfile option. I would need to support that if I'm going to customize the init function. So one of the things that I would have to do is actually make sure that I also accept that argument from the parent class. I would at least need to account for it in some way. So if I had a custom init, I would need to deal with that. One of the things that I would also need to deal with is initialization of my parent. This is one of the problems in adding new attributes is I would have to initialize the parent. If I don't do that, all sorts of things are going to break. And then I would have to save my new width parameter. So this is one challenge that comes up. Honestly, this is actually a very tricky thing with inheritance is that if you have more than one init function, you're going to have to figure out some way for those to compose together or account for that in some manner. As far as using that width, by the way, this will test your esoteric knowledge of string formatting, but one of the things I can do is replace the 10 in there with another set of curly braces and then plug in my width there. This probably falls into the category of increasing job security or something. Essentially, what you can do is kind of change the width there. This is one challenge. If you had that extra argument, you would have to account for that. Let's just make sure that that works. So I'm going to make a formatter, text table formatter, where I can specify the width is maybe equal to 25. And then I should be able to do print table, portfolio, name, shares, price, formatter. That looks like it works, but it is a little bit tricky, the fact that I have my own init function on there. And I have to worry about that this out file also possibly being supplied there. Here's another kind of tricky thing with inheritance. Somebody might actually want to customize the text table formatter in some way. I mean, one of the big ideas with inheritance is that you can take an existing class and then customize it in some way that you want. Maybe somebody is going to do something like this. They would say, actually, I want to make a custom formatter that inherits from text table formatter and then does some kind of tweak on it. Actually, instead of calling it formatter, maybe I want to do something like this. I'm going to make something called quoted text formatter, table formatter. What I'm going to do is redefine the row method to put quotes around everything. What I'll do is I'll take all the data. I'll say quoted is essentially equal to double quote with something format D for D in row data. So I'm going to take all the data, just drop it inside double quotes. And then what I'll do is kick that up to the parent. I'll say, well, now do the normal row with the quoted data. This is this idea of taking a method and wrapping it in some way. So what I could do here is I could say formatter is equal to quoted text table formatter, like that. And then I could do my print table on it. Let's do my print table there. What I should see is it's now altered the output. I mean, essentially what's happened is it's taken all the rows and it's dropping double quotes around it. Put that up there for a second. Turns out that this also presents kind of an interesting problem with inheritance. Let's focus on this code for a second. What we have is we have a method that puts quotes around the values, but it doesn't really have anything to do with text table formatting specifically. Like maybe I want to have quotes for a CSV table. Maybe I want to have quotes for an HTML table. It seems a little weird that I've attached this to the text table formatter class. It's like some kind of tight coupling, basically, where it's like, I don't know whether I like it just totally married to that. And so what I'm going to do is show an example of using multiple inheritance, actually. It turns out that this problem can be solved in a different way. I'm going to make a class called quoted mixin that just inherits from object, has no relation to table formatter. And I'm going to take that row method and I'm going to drop it in there and put exactly the same code that I had down below. So I'm going to put quotes around things like that. And I'm going to use the super function to just pass it along. So this is going to look really odd. This is a class. It has one method in it and nothing else. There's no parent. There's no other code in there. All it does is it takes a row, puts double quotes around it, and then uses the super function. It turns out that this technique, or the thing that I'm doing here, is an example of where you might consider using multiple parents or multiple inheritance in Python. One of the things that you can do if you do that is you can use it to combine with one of the other classes. So let's say I wanted quotes on like a CSV table. I can make a class. I can say I want to make a formatter that inherits from quoted mixin and then also inherits from the CSV table formatter class. What's happening here is this is taking advantage of the fact that if you have more than one parent, they kind of merge together. What's going to happen is this row method that I've got here is going to merge with the row method on the other class. This might blow your mind when you see this, but what I'm going to do is make a formatter. I'll then do print table. We'll pass in our portfolio and do names and shares with that custom formatter. And all of a sudden you see the quotes on the field. It essentially combined the functionality of the quoting and the CSV. If I wanted to do HTML instead, I can plug that in there as well. So let's plug it in. We'll make a formatter the same way that we did before, and then use that to print a table. Again, we get quotes on the different values. You might look at that and say, well, that's completely insane. That is actually probably the big use of things like multiple inheritance in Python. And it is something that is used occasionally in libraries and frameworks where you might have a library that provides some kind of basic set of classes, like these table formatting classes. And then what it will do is provide, for lack of a better word, add-ons, like little optional features that you can incorporate. One of the ways of incorporating the optional features is to do this technique that I just did with this mixin class. It might be a class that just defines like an isolated method, all by itself. And then the idea is you would combine that with one of the other classes. Think Lego blocks, things like that. You're putting code together in an interesting way. So these are kind of advanced things that come up with inheritance, overriding attributes, customizing classes, things like mixins. You will see those in kind of more advanced Python code.